objects are included in our solar system? Our solar system includes our sun, which is a star, and we'll talk about stars next week. 8 planets and their satellites or moons, which we've already talked about, and then many other objects that we're going to talk about in this video. Asteroids, comets, meteoroids, dwarf planets, the Kuiper belt, and the Oort cloud. So here's a cartoon of our solar system. Remember that the Kuiper belt, which rhymes with viper, is a region of icy objects beyond the orbit of Pluto, and actually it includes Pluto. The asteroid belt is a belt of small rocky objects that are primarily located between Mars and Jupiter, and we're going to start there. So asteroids are defined by their size. They're greater than 100 meters in diameter, and that's about the same size as a football field. Most of them, as I mentioned, lie in the asteroid belt between Mars and Jupiter. They're not very large. The largest one is about 620 miles in diameter. This is a picture of it, and it's called Ceres, and it's actually been now classified as a dwarf planet. And we'll talk about what that means near the end of this video. Some asteroids have very eccentric orbits, which means they're highly elliptical around the sun, but most of them are just going in a circular manner around the asteroid belt. Many of the recent impacts on the Moon and Earth have come from the asteroid belt. These objects have irregular shapes. They're not necessarily spherical because they're not big enough to pull themselves into a sphere. In fact, that's why the planets are spherical, which I haven't really mentioned, is that they're so massive, they've pulled any irregularities down to make a spherical shape. The origin of the asteroids is uncertain. Some scientists believe that the belt was a planet that broke up. Others believe it was debris that never formed into a planet. So the more we study them, the more we might be able to determine that. Here are some pictures of some asteroids, and this one has this crazy little feature called the snowman on it. Here's an asteroid that's really interesting. It's called asteroid Bennu. We are currently in the process of collecting samples from this asteroid and bringing them back to Earth. One of your homework assignments this week shows a short video of this project. Meteoroids are basically just small asteroids. They are less than 100 meters in diameter. When they enter Earth's atmosphere, they're called meteors. And so sometimes you see a flash in the sky, and that's a meteor. Sometimes these are called shooting stars or falling stars, but they're not stars. Believe me, if a star fell to Earth, we'd know about it. These are just little objects that burn up in the atmosphere, and so they glow. Sometimes Earth passes through the debris of a comet that had once passed through our solar system. And when we do that, the debris from the comet produces a meteor shower on Earth. So lots of little bits of meteoroids hit Earth's atmosphere. Your homework this week also covers the Perseid meteor shower. And then if it actually makes it all the way to the ground, we have a meteorite. Here's a meteorite. And here's a hole created by a meteor. This one's in Arizona, and you can visit it. So do we have anyone looking out for meteors and, more importantly, asteroids that might hit the Earth? Of course we do. This is from one of my favorite web pages, spaceweather.com. And every day they will give you an all-sky Fireball Network review and a near-Earth asteroid list. So the Fireball Network shows you where fireballs come and hit Earth. So this is showing the Sun, Mercury, Venus, and there's Earth, blue. The little blue dot is Earth. And so this is showing the orbital trajectories of the fireballs that hit Earth. So there are 3 in this particular picture that hit on September 14th. And the color has to do with their speed. But more of concern are the near-Earth asteroids. Now these are objects that come closer to Earth than 0.05 AU, so that's 5% of the distance between us and the Sun, and they're larger than about 100 meters. Those are the potentially hazardous ones. This list shows all that we know about. We have the name of the asteroid, the date that it's going to come its closest to Earth, the miss distance. Okay, so how much is it going to miss us by? And LD means lunar distance. In other words, the average distance between the Earth and the Moon. So the first one on the list here is going to miss us by 4, or already did, miss us by 4 lunar distances, and so that means it's going to be 4 times farther than the moon at its closest. We have its speed, and then we have its size. You'll notice that most of these rows are yellow, but some are peach or even a darker peach. The darker the color, the more concern it is. So for example, this one here is only 9 meters in diameter, but it's coming pretty close. There's one down here that's coming 0.2 lunar distances from us. That means its closest approach will be inside the orbit of the moon, 4/5 of the way to the Earth's surface between the moon and the Earth. And that one is 7 meters in diameter. So here's one that's 69 meters in diameter. That's a lot more of a concern because it's so big, but that one's going to miss us by almost 18 lunar distances, etc. So this is a great website to go check out for fun stuff like that. Okay, so the meteor showers that we pass through, the old comet debris, we pass through every year at the same time because here's our orbit, and if the debris is right here, then every time we pass here, we're going to go through that same debris. So that's why we know the dates of meteor showers, and we give them a name based on the constellation from which they seem to be radiating. The Perseids, which is also in your homework this week, come around August 12th from this comet. And again, it's because we're going through the debris when that comet came through. So what are comets? Well, comets have one big difference between asteroids and meteoroids, and that is that they are composed not only of rock, but also of frozen gases. And so sometimes we call them dirty snowballs. The frozen gases vaporize when the comet gets near the sun, and so they start to glow. The head of the comet is called a coma, and then a tail points away from the sun due to radiation pressure and the solar wind blowing material away from the sun. Here are several shots of Pan-STARRS, which was a comet that came through in 2013. You can see the glowing head and the tail of gases quite nicely. And when these things come through, they don't shoot like a meteor. They hang out in the sky for weeks. Here's a comet called Comet Lovejoy. It's one of 6 Comet Lovejoys. There's an amateur astronomer in Australia who finds these things with his cameras, and so they name them after him. This one's kind of interesting because the tail actually divided into 2 pieces, 2 strips here. It almost looks like the eye of a needle. And the coma is glowing a very unusual green. So here are 3 time-lapse photos of a comet that was visited by a robotic spacecraft called the Rosetta. What you see jetting out here is some sort of vaporization of those icy gases. And so these are really interesting things that scientists like to study to try to figure out what kinds of things these comets are made of. So their origin is not well known. We believe they form very far from the sun, which is why they've got frozen gases associated with them. The most famous one is Halley's Comet, which comes through every 76 years, and its next visit is 2061, so you'll probably be here for that. It's even been noticed in the Bayeux Tapestry, which was created depicting the 1066 Battle of Hastings, when William the Conqueror conquered England. And so right here, there's an object called Stella, which means star. There's the object, and here's people looking at it. And that, we believe, is Halley's Comet. Beyond Pluto, we have the Kuiper belt. And the Kuiper belt is this region of icy objects from about 30 to 50 AU from the sun. And they're very, very small. We believe that short period comets come from this region. And when I say short period, I mean comets that orbit the sun in 200 years or less. Pluto's orbit is shown here in yellow, and Pluto is now considered a dwarf planet, so let's move on to dwarf planets. This was a new class of planets defined only recently, and the key is that these were objects that do orbit the sun, but have not cleared their space, their orbital path of objects. They haven't gravitationally pulled everything and cleaned everything up in their space. And so that's what defines a dwarf planet. There are 5 dwarf planets in our solar system that we know of right now. Pluto is, of course, the prototype of this category. And again, these are generally located in the Kuiper belt beyond the orbit of Neptune. Pluto is not visible with the unaided eye. It was only discovered in 1930. It has a moon called Charon, which was discovered in 1978. And then only recently have we discovered these 4 smaller moons as well. So in this picture, you can see Charon, at least its size, compared to these 4 other objects. There's a little scale bar here that says 10 miles or 10 kilometers. So these are really, really tiny objects. The temperature on Pluto, including everything else out beyond Pluto, is very, very cold, negative 210 degrees centigrade. Oops, not that Pluto, that Pluto. So here's Pluto and Charon, their sizes placed on a map of the United States to give you an idea of how tiny these objects really are. And here's a photo of Pluto, Charon, and 2 of the other 4 moons. The New Horizons spacecraft flew by Pluto very closely in 2015, and here's an image from it. And now New Horizons is continuing through the Kuiper belt to discover various objects that it comes across. Here's another dwarf planet called Makemake, and this is shown in 2 places because it was taken 2 nights in a row and then superimposed, so you can see it twice because it moved. And it just so happens that in this image of the sky, there's also a beautiful spiral galaxy about 41 million light years away. Here are those 5 dwarf planets, Makemake and Haumea and Eris. Really, we don't have an idea of what they look like. These are artists' renditions. But this is a photo of Pluto, and this is a photo of Sirius, the one that's in the asteroid belt. Finally, the Oort cloud. This is not even real. This is theoretical, but maybe by the time you're my age, it'll be something that we have confirmed. So for size, here is the Kuiper belt that I just talked about, which may be as far as 50 AU from the sun. And that whole area is just this little blue blob right here. And everything else is icy objects that seem to be the source of long period comets. Comets that have elliptical paths that take 1 million years for one revolution. Coming up next, the Earth.